Ayo, Chapter 7. Last chapter we're going to work on for the winter semester. I'm going to break it into two parts. Start with our introduction, where we focus just on the square root property that plays a role in this chapter. And then part 2, we'll talk about actually completing the square. So our big key concept here to know is a squared equals b squared. If that is true, then we know if we take the square root of something squared, we get the radical or the radicand as the answer. The exponent and the radical symbol fall away. The square root of a squared. Say a is 2. If a is 2, 2 squared is 4. Square root of 4 is 2. It just brings us back. So what we're doing is, whatever we do on the left, we do on the right. Same concept we learned long ago for equations. Now, if we take the square root of a squared on the left, we have to take the square root of b on the right, and then we even everything out. The square root of a squared is a. Square root of b, we have to say plus or minus b, because we're talking about squareds and square roots. This could have been a -2 or a 2. So our answer is going to entail a positive and a negative. So let's start examples here to get a better sense of what's going on. Now, in class, I would work through the long way to do this, but because of time on the videos and publishing and everything, I won't. You could take this and you could expand it. You could take 2x minus 3 times 2x minus 3, get your whole answer. You could factor a 4 out and solve your two possible x's in the long way. However, when we have something squared on one side, we can get rid of it by taking the square root, and it makes things a little quicker. So what I'm going to do is take the square root of 2x minus 3 squared. Think of this as our a, and this is our b. So we have a squared. So we take the square root of it. So I'm taking the square root of only the piece squared. Remember that. If you have another component, only take the what's squared. So the square root of the left equals the square root of the right. All I did was slap a square root symbol on both of them to keep them equal, keep them even. This equal is a key. So I know square root of something squared leaves me with the something, basically, the radicand. Now, square root of 25, that's 5. However, it could be a positive 5, it could be a negative 5. Negative 5 times negative 5 is 25. Positive 5 times positive 5 is 25. So we have this piece. This is going to play a key role. We want to keep this piece at the end. Now, we're down to a simple equation. We have to solve for x. To solve for x, we add our 3. But like I said, we want to keep that 3 out front. We always want to add and subtract at the end. So we'll leave our plus minus at the end, factor our 3 in here. Now I need 1x, so I divide by 2. What I do on the left, I do on the right. Here's technically my answer, 3 plus or minus 5 over 2. However, that's two different answers. We have 3 plus 5 over 2. We have 3 minus 5 over 2. 3 plus or minus 5 over 2. I can combine all these, so I have to separate them. If you can't combine them, then you can just leave it as plus or minus. You'll see in the future. 3 plus 5 is 8. 8 divided by 2 is 4. There's one answer. 3 minus 5 is negative 2 over 2, which is negative 1. There's my other answer. So x equals 4 or negative 1. Okay. Let that sink in a minute. We'll do 2 more examples for this intro, and then we will move to completing the square. I didn't want to try and jam them all in one video just due to time. Also, if you understand this concept, you can jump right to part 2 for completing the square to get a better feel for that concept. So example 2, let's see, they give us solve for x, and they give us 3x minus 1 squared equals a negative 12. So they switch it up a little bit here. Now they're giving us a negative. They're giving us something that's not a perfect square. So I'll write it all out. You don't have to write it all out when you're doing these on your own. If you understand what's going on, you can just write 3x minus 1 equals square root of negative 12. You can skip some of this. Square root of negative 12. Now, when you pull the I out, It doesn't really matter. You can pull it out right away. You can say that's I squared root of 12 if you want. I sometimes like doing that. You could think of it as a negative 4 times 3, and there is a perfect square to negative 4. So you could pull out your 2i and say, well, negative 4, square root of 4 is 2. It's a negative, so I pull out an I. 2i times the square root of 3. I should have put my plus or minus in here. So 2i, wherever you want to pull it out, pull it out. You can pull the I out. The minute you see a negative, you can go ahead and pull an I out just to get it out there so you don't forget. Or you can factor everything out and keep your negative with what you're pulling out. That might make more sense. Go whichever route you want. But either way, you have a 12 under the radical sign. So you break it down to a 4 and a 3, because there is a perfect square to 4. So we have plus or minus 2i. You have to have the plus or minus in there. I waited because I was focused on what's underneath. Plus or minus 2i squared root of 3. Here is our right side. I just worked at that. Here is our left side. So I have to add 1. So I have 3x left over here when that goes away. I have 1 here, plus or minus 2i times the square root of 3. I just leave this out front. This is my chunk that stays together. I'm adding that and I'm subtracting that, so I have to keep that together. Now I divide by 3, and I divide the entire piece by 3. So what we have is my x is 1 plus 2i squared of 3 over 3, and x equals 1 minus 2i squared of 3 over 3. In this case, this is different than the first one because we can't combine those. There is nothing to add. I have a 2i and I have a square root of 3, and I have a 1 and a 3. I can't do anything with that. So in this case, I can just leave my answer as x equals 1 plus or minus 2i times the square root of 3 all over 3 and show here's my 2 answers. Because I can't combine them anyway, it just gets messy doing it this way. I can just say this. This means that. The first one we had to break them apart because we could add. They were all numbers. We could add them together and get 2 specific answers. Here, they're messy. There's no clean answer, so we can just write it plus or minus. Okay, let's work one more example for this introductory part before we move to the idea of completing the square. And I'll clean the whiteboard before that too. Okay, so example 3. For example 3, now they have the expanded form. X squared plus 6x plus 3, or plus 9. I'm already thinking about breaking it down. Plus 9 equals 12. This is the last one we're doing because it shows it expanded. We want to see if there's a perfect square in there. This also jumps us toward how we complete the square. When we're completing the square, we're looking at these perfect square pieces. Well, if you look at this, you could go, we'll go the long route. We will, for now. We'll go the long route. X and x, if you start factoring, you have a positive 9. So it's 2 negatives or it's 2 positives. So we look at this, we know they both have to be positive. 9 can be broken down into 3 and 3, which added together is 6. What we find is that we actually have a perfect square. They just had it in expanded form. So once you factor it out, now remember, use the book as a guide. The book wants us to use perfect squares. My cat's messing with the camera right now. Once we have a perfect square, then we can take the square root. Without it, we can't do anything in this chapter. We have to find a perfect square or use a perfect square. So for a couple of these, use the book as a guide and know, well, I'm probably going to have a perfect square in here somewhere. And it takes a little bit of the guesswork out of factoring. So I need to take the square root of each side. When I do, I have my x plus 3 over here, plus or minus square root of 12. Same thing we had earlier. We know what the square root of 12 is, and I'll move up here. I'll move up here to break it down. So we have x plus 3 equals the square root of 12. You know, and I know right now I'm going back in time, but section 6.2, a lot of students were having difficulty with section 6.2. It's where you have to factor down what's inside and look for perfect squares, perfect cubes if your index is a 3. I have a 4 times a 3 to get 12. 12 can be 4 times 3. There is a perfect square to 4. So what we have is x plus 3, I'm just waiting to move my 3, equals, I'm going to pull a 2 out. My answer is always plus or minus because of this, the square root. So plus or minus, I'm pulling a 2 out because the square root of 2, this is like saying square root of 4 times square root of 3. You could write it, you could separate them. Square root of 4 is 2, there is no perfect square of 3. There's my piece, there's my chunk. Now to get x, I need to subtract my 3. X equals negative 3 plus or minus 2 times the square root of 3. So x equals negative 3 plus 2 square root of 3. X equals negative 3 minus 2 times the square root of 3. We got there by checking to see if there was a perfect square. There was, x plus 3 squared. This is x plus 3 squared. So then we take the square root of both sides. And this is kind of our introduction that gets us ready for completing the square. I think that was the only one that I wanted to do, yeah. So example 4 is what we'll do in part B of this 7.1 video. We'll have a separate video for that one, and it'll be completing the square before we move into section 7.2. Hope you had fun with that. I sure did.